Hey everybody, I hope you all are doing well and I hope the spirits are high for the upcoming chemistry MCQ paper. Basically, quite a few students sent me a few worksheets claiming that they were the most difficult MCQs that Cambridge had tested up until this point, and they were the same worksheets over and over again. So what I did was I compiled these worksheets into one, and I thought of making a video solution for you guys so that you all can safely enjoy solving the most quote unquote difficult questions that Cambridge has tested, right? And I'll also upload the white background version of it in the description by tonight or tomorrow so that you guys can download it and attempt it on your own first and then refer to this video solution, right? Okay, so question number 1 says substance M is a solid at 30 degrees Celsius, and 30 degrees Celsius is just right here between 20 and 40. I hope everybody knows that, right? So that's my solid. And you know, the examiner is trying his level best to confuse us by telling us that there is a change of state when you cool down a solid. And we know that that's absurd. You know, you only have 3 states of matter for O levels and A levels and IGCSE, obviously, which is solid, liquid, and gas. And he's saying that if you further cool this solid down at like 20 degrees Celsius, it's going to change state. Oh, you dumbo. Where will this solid go? If you further cool down a solid, it remains a solid. So there is no change of state. Remember guys, whenever you have a horizontal line on a heating curve or a cooling curve, that means that there's a change of state. And we've done all the reasoning for it. I don't want to go into that detail. But there's a solid right here. Now he's saying, between which times is the substance M freezing? Now, before I talk about freezing, you need to understand that if this is solid, obviously from Q to R, you must have had a liquid changing its state into a solid, right? And that's basically at around 40 degrees Celsius. So at 40 degrees Celsius and before 40, when you were at like 80, when you were at 80 and coming down all the way from 80 to 40, you had a liquid, right? So you were cooling down a liquid up until which point? Up until 40 degrees Celsius, where this liquid started to change its state into a solid, and that is why you had solid at 30 degrees Celsius. And thus S to T is totally wrong. There is no change of state after you get a solid, right? At least for O levels and A levels. Done? So here he's saying, between which points is the substance M freezing? Freezing is what? Freezing is the process of converting a liquid into a solid, and freezing point is the constant temperature at which a liquid changes its state into a solid. So that's between Q and R. And if I asked you what was the freezing point, that would be 40 degrees Celsius. So Q to R, therefore B is the correct option. P to Q, if you check P to Q, that's basically liquid further getting cooled down. R to S is basically a solid getting cooled down, and S to T is totally wrong. There's no such thing as S to T, right? Now, this particular question says the equation of thermal decomposition of sodium hydrogen carbonate is shown. The MR of sodium hydrogen carbonate is 84. The MR of sodium carbonate is 106. In an experiment, 2.1 grams of sodium hydrogen carbonate is heated, but not all of it decomposes. Now, the question is, how much decomposes? We do not know that. So we cannot use this 2.1 grams for our calculations, because whenever you want to perform calculations with stoichiometry involving moles and so on and so forth, you need to have concrete data, right? So we're saying you had 2.1 grams, but not all of it decomposed. Then it means that you do not know how much reacted. If you don't know how much reacted, you can't use this equation. But the beauty is, here he is also giving you another data, which is saying the total volume of carbon dioxide produces 0.21 decimeter cube. So he's given you the amount of carbon dioxide being produced, or the volume of carbon dioxide being produced, which you can use to your advantage to calculate different substances, right? So calculate how much sodium hydrogen carbonate was needed to make this much amount of carbon dioxide, how much sodium carbonate formed and this much by using this much carbon dioxide, how much H2O formed, right? So this is my concrete known data that I'm going to use, right? Done? So now the question says the volume of 1 mole, we obviously know that. It's saying which statement is correct. The mass of sodium carbonate produced is 0.93 grams. Obviously, to check these two out, we have to calculate the moles of carbon dioxide produced, and then from the moles of carbon dioxide, we're going to use the equation to jump to the moles of sodium carbonate, and then we're going to use the MR to go from the moles of sodium carbonate to the mass of sodium carbonate, right? So let's do this. Here we have 0.21 decimeter cube. We know that 1 mole of any gas at room temperature and pressure occupies a volume of 24 decimeter cube. So if you had 0.21 decimeter cube of carbon dioxide being formed, how many moles of carbon dioxide were there? So 0.21 divided by 24, that gives me 8.75 into 10 raised to the power minus 3. And then we use the equation to find out the moles of sodium carbonate. We know 1 mole of carbon dioxide, when it was being produced, you had 1 mole of sodium carbonate. So 1 mole of sodium carbonate was produced along with 1 mole of carbon dioxide. Well, if I had 8.75 into 10 raised to the power minus 3 moles of carbon dioxide, how many moles of sodium carbonate would be produced? And the same amount, which is 8.75 into 10 raised to the power minus 3. Obviously, if you guys are good at math, you know it's 1:1. So the moles of carbon dioxide that you are getting produced, that will be the exact same as the mole of sodium carbonate, and you could further prove it by cross multiplication. Done? And now let's calculate the mass of sodium carbonate. So we know that 1 mole of sodium carbonate is going to have a mass of 106 grams, right? So 1 mole has a mass of 106 grams. So if you have 8.75 into 10 raised to the power minus 3 moles, how many grams would you have? X cross multiply, you're going to get this much into 106. That's going to give me 0.9275, and you could safely round it off to 0.93 grams, which is a Reno. Done? Now, the examiner is also giving you some other options. He's saying the percentage yield of carbon dioxide is 10%. The percentage yield of carbon dioxide is 35%. You could automatically cancel C and D out. Why? Because you do not know how much carbon dioxide would have been produced theoretically, right? You cannot determine how much carbon dioxide would have been produced theoretically. How can I not determine that? Because you do not know the sodium hydrogen carbonate that reacted. If we knew the amount of sodium hydrogen carbonate that reacted, we could use that to our advantage to calculate the moles of carbon dioxide or the volume of carbon dioxide that we would have gotten theoretically. This volume, we are getting this practically. Here he's telling you the total volume of carbon dioxide produced. This is a practical value. You cannot calculate the theoretical value. Why? Because you do not have the amount of sodium carbonate that actually reacted, that actually decomposed, right? Done? So that's why C and D were wrong. Okay, so this particular question says, which method produces the salt copper carbonate? Now we know that all carbonates are insoluble except for group 1 carbonates and ammonium carbonates. That's our solubility rule. So copper carbonate is an insoluble salt, right? And we know to produce an insoluble salt, we use the precipitation method, in which you use 2 soluble salts of this compound. So for copper, we're going to use maybe like copper nitrate or copper chloride, because all nitrates are soluble, copper chloride is soluble. You need to know your NACSAG rules, right? And for carbonate, I might use sodium carbonate or any group 1 carbonate, or I can also use like ammonium carbonate. So who cares, right? These 2 carbonates are soluble. All group 1 carbonates are soluble, right? So you could use sodium carbonate, and here you could use ammonium carbonate. Done? Now it's saying add copper oxide to water. Sir, copper oxide does not dissolve in water. It's insoluble. So that is absolutely wrong. Copper oxide is insoluble in water. So nothing's going to happen. Copper oxide, add copper oxide to dilute sulfuric acid. Okay, look at this. Look at this. Let's follow what the examiner is saying. So add copper oxide to dilute sulfuric acid. An acid-base reaction is going to take place. We know that copper is going to react with this sulfate ion to produce copper sulfate, and H2 and this O are going to give you H2O. So whenever you have a base, because copper oxide is a basic oxide, right? So whenever you have a base and you have an acid, this basic oxide here is going to react with this acid, and it's going to undergo an acid-base reaction. So copper sulfate is going to form a salt, and you are going to end up with H2O. Now copper sulfate is aqueous. Why? Because all sulfates are soluble except for LMS castrobar, right? And in your course you only need to know that lead sulfate and barium sulfate, they are insoluble. So copper sulfate is a soluble salt. Now if you have copper sulfate right here, If you have a copper 2 plus ion and a sulfate ion, and you are adding sodium carbonate to it, and we know sodium carbonate is also soluble, so you're adding sodium carbonate, what's going to happen? Well, eventually, when this copper ion comes into contact with this carbonate ion, they're going to form a precipitate. Boom shakalaka, they're going to solidify. Yeah. So they're going to give you a solid, a white precipitate. Done, sir? I don't know if it's white. No, it's not. It's not white. I think it's green. I don't know. But pretty much that's what you're going to get. So you don't need to know the color of copper carbonate. Let me just search it up. Wait. Color of copper carbonate, sir. It's green. Yeah, it's green. I was right. I was right. Okay, done. So B is the correct option, right? If you look at C saying add copper to dilute hydrochloric acid, so this is also right off the bat wrong, because copper is not going to react with dilute hydrochloric acid. Why? Because copper is less reactive than the hydrogen in the acid. It's below hydrogen in the reactivity series. Done. And he's saying add copper oxide to excess aqueous sodium carbonate, filter off the precipitate. Sir, copper oxide is insoluble in water, so when you filter off the precipitate, what's going to happen is you're going to still end up with copper oxide, right? Sodium carbonate and copper oxide are going to undergo no reaction because both are bases. Done. Which statement describes how the CH bonds in methane gas in the atmosphere contributes to global warming? Now, they absorb thermal energy from the sun, from the earth. Remember, they do not absorb the thermal energy from the sun. Therefore, A and B are wrong. And you could ask me, why, sir? Well, I would tell you to revise your environmental chemistry, because what you need to understand is that the sun, I'll give you a good short explanation to it, right? So when the sun, it produces radiation, it gives off radiation which has a very high frequency, right? So if this is your earth, this is the atmosphere, right? This insulating layer or this blanket is your atmosphere, which contains all these gases. So it contains this carbon dioxide, it contains the H2O molecules, it contains methane. You know, H2O, which is water vapor, is also a greenhouse gas. Fun fact, right? So when these rays are being given off by the sun, these molecules right here, they cannot absorb these rays. Why? Because they have a very high frequency, because the sun is very, very hot, right? So they have a very high frequency, so they can penetrate through this atmosphere and hit the earth, and therefore this is how our earth gets warm, right? But what happens is when it hits the earth, some of it reflects back, right? And when it reflects back, because the earth is relatively cooler, the radiation that reflects back has a very high wavelength. So it has a longer wavelength. When it has a longer wavelength, and because the earth is cool, it will have lesser energy. Therefore, this carbon dioxide molecule, these CH4 molecules, this H2O molecules, they're going to trap in this heat. They're going to absorb it, further heating our earth up, right? So that is why these global, these greenhouse gases cause global warming, right? So so the thermal energy is absorbed from the earth. Why? Because they have a longer wavelength, it has less energy, and it says and emit all of this energy towards the earth. That's wrong. It emits energy in all directions. So some is lost to the space, some is emitted towards the earth. You know, it emits energy in all directions. So now it says they absorb the thermal energy and emit some of this energy towards it. Yes, that's true. Some of it is lost to space, right? So D is the correct option. C, therefore, is wrong. Moving on. What is the structure of the product of the... Remember, guys, I am solving this MCQ paper with you all in a very detailed manner. So I don't want to rush into the options. You guys can rush into the options and quickly, cancel out all the options and just circle one of it. But I want to focus more on the concepts, right? Because obviously these MCQs will not be replicated in the paper. The concept will remain the same, remember. So now it says, what is the structure of the product of a reaction of propene with bromine? Remember, guys, if I say that's my propene molecule, meth, eth, prop, right? And because it has an E, that means it's an alkene, right? And here you have the carbon-carbon double bond. Done? Now, what's going to happen is when it reacts with bromine, which is Br2, this carbon-carbon double bond is going to break, and once this carbon-carbon double bond breaks, a bromine atom is going to be bonded here, and this bromine atom is going to be bonded here. Remember, wherever the double bond breaks, the new atoms are going to be bonded here. It's not like the double bond is breaking here and you're taking this bromine atom and adding it over here. No, this carbon already has all its bond completed, right? When this double bond breaks, a valency is created on this carbon as well as on this carbon. Why? Because then they would have only have made 3 bonds, and the 4th bond would be missing for this carbon. This carbon would have made 3 bonds and the 4th bond would be missing for it. So a bromine atom would be bonded here and another would be bonded here, right? Done. So if I show you guys this is the kind of structure we had, and now I've broken the double bond. So if I've broken the double bond, here you had the double bond, now it's broken. Now the bromine atom, oh my bad, the bromine atom is going to be bonded right here, and the other bromine atom is going to be bonded here. Remember guys, it does not matter how you position it. So you could add the Br here, you could add it here, the examiner could add it here, show it here. The position of it does not matter as long as you are adding it on the carbons where the double bond breaks. So it can be added here at the top as well, at the bottom, at the top, at the bottom, at the side. Who cares? The examiner can do everything to confuse you. Now see, B is off the bat wrong because he's already shown you the double bond. That means this is just stupid, right? There's no addition reaction that you are seeing here. The double bond must break for the bromine atoms to be bonded. Done. If you check A out, A is also wrong because he's only added 1 Br atom, and we know that it's not a substitution reaction, an addition reaction needs to take place. Now see, that's what he has done in C and D. He's just confused you with the position of the bromine atom. See, as long as one bromine atom is on this carbon and the other is on this carbon, it does not matter whether it's at the top, at the bottom, here. So you could safely say that C is the correct option because the bromine atom is bonded right here on this carbon, and this bromine atom is bonded right here on this carbon. So C is the correct option. Why is D wrong? Because what we feared the most, he has put a bromine atom here and then he's put a bromine atom on the first carbon. So on the first carbon and on the third carbon. That's so stupid. The double bond is breaking here and he's putting a Br atom here and a Br atom here. So that's wrong. Done? And says part of the structure of a polymer is shown. Done and dusted. Which polymer are we talking about? Well, if you want to find out which polymer it is, put a cut at the linkage. So put a cut at the linkage, put a cut at the linkage. This is my linkage, carbonyl carbon bonded to the NH, the amide linkage. So I'm putting a cut here, putting a cut here. Between 2 cuts, you're going to have your monomer. So between 2 cuts, you're going to have your monomer, right? You can put cuts here at the connectivity bonds as well. Now if you check this out, here you have the amine group, and this group came from the amine bit and this group came from the acid bit. So amino acid. So if the monomer is amino acid, therefore the polymer should be protein. Done. So it's not nylon, it's protein. If it were nylon, you would have realized that you would have the nitrogen atom and the other nitrogen atom bonded on the same box, and 2 carbonyl groups on this particular box to the left and right hand side, right? 2 carbonyl group of atoms. Done. So that's basically protein with me. It's not nylon. So you're saying the polymer is nylon? No, sir, it's not nylon. The polymer is formed from a condensation polymerization. Absolutely, it is a condensation polymerization because a small water molecule is being removed. Done? And in A levels, you're going to learn acyl chlorides and then more about that. But in this case, water molecules are removed. There are ester linkage. Oh, you dumbo. They are amide linkages. Ester linkage is the carbonyl carbon bonded to the O. That's the ester linkage. Yes, dumbo jumbo. That's the ester linkage. This linkage, carbonyl carbon bonded to the NH, that's called the amide linkage. So basically I'm going very, very slow because we want, what's in my mind is that even if a person has never studied conceptually before, his concepts get cleared so that he can easily attempt the paper after this. Done? Okay, so this particular MCQ says, why is cryolite used in the extraction of aluminum by electrolysis? Well, there are 2 reasons why you use cryolite. Number 1 is that cryolite lowers the melting point, right? And when cryolite lowers, why does the cryolite lower melting point? Well, obviously because it is an impurity, and we know that impurities decreases the melting point and increases the boiling point, right? And why do we need to lower the melting point? Well, obviously it's common sense. Industrialists only care about money. So aluminum oxide, if you want to extract aluminum out of it, aluminum oxide has a very, very high melting point, right? Because it's an ionic compound with strong electrostatic forces of attraction. So unless and until you add cryolite to it, which is an impurity which will lower your melting point and save electricity cost, it's gonna cost you a hell out of money if you don't add this impurity. Done? And the second reason, and then when it lowers the melting point, the aluminum oxide easily dissolves, and you could start your process. And the second reason why it's used is because cryolite also helps in, wait a second, I'm getting a text. Okay, cryolite also helps in what's it called, improved electrical conductivity. So it also helps in electrical conductivity. It improves the electrical conductivity. So please add the word improves, right? Add improves here. Improves electrical conductivity. Now, why does it do that? You guys don't need to know. It's basically cryolite is sodium hexafluoroaluminate, right? So Na3Al(F6). You guys don't need to know this, but when you add cryolite, there are a lot of ions that are going to be moving, just like the sodium ion, right? Because it has sodium in it, so a lot of sodium ions will be moving, and because you have free moving ions, they are going to carry the charge, and if they can carry the charge, it will help in electrical conductivity. So it improves the electrical conductivity of the solution, so electrolysis can take place easily. So A says it dissolves the aluminum oxide. Absolutely it does. When it lowers the melting point, the aluminum oxide goes from a solid, and just with a little bit of heat energy, it goes into a liquid, right? So it dissolves, absolutely. So A is correct, but if you look at all the other options, they say it protects the anodes from corrosion. That's so wrong. If it protected the anode from corrosion, then the anode wouldn't corrode when oxygen was formed at it. But we know that when oxygen forms at the anode, it reacts with the graphite electrode to produce carbon dioxide, and that's why extraction of aluminum is taking a toll on this environment, because carbon dioxide is a greenhouse gas which causes global warming. It changes bauxite to aluminum oxide. Bauxite is aluminum oxide, you dumb person. Large chunk of it. It decreases the melting point of aluminum? No, it decreases the melting point of aluminum oxide, of bauxite, of aluminum oxide, and that aluminum oxide then therefore dissolves. So not of aluminum oxide. It says methane. Now the next question says, methane reacts with chlorine in substitution reactions. Done. How many different products containing a single carbon atom can be made during the reactions? Remember guys, the number of hydrogens that you have are the number of different organic products that can be formed, right? So if you have 4 hydrogens, you can safely say that 4 different organic products are going to form. Why? Because this is a chain reaction. Every time a hydrogen is going to be substituted by chlorine atom, what's going to happen is you're going to get CH3Cl, and the hydrogen atom that has been substituted is going to react with the chlorine atom to give HCl. Now this CH3Cl will further react with chlorine to give you CH2Cl2 plus HCl. What's going to happen is another hydrogen atom would be substituted, and this hydrogen atom substituted will react with chlorine atom to give you HCl. And remember, this reaction will go on and on and on. If you've added excess chlorine, it will go on and on and on until all the hydrogen are substituted, right? So again, CH2Cl2 plus Cl2, a chlorine atom substitutes a hydrogen atom, and the hydrogen atom substituted reacts with the other chlorine atom to give HCl. So CHCl3 plus HCl, and then you have CHCl3, last hydrogen to substitute, so add chlorine to it. Boom shakalaka. I drew the arrow wrong. Drawed. Oh my god. Yalla habibi. And so what's going to happen is you're going to get CCl4 plus HCl. So how many different single carbon atom products were formed? So single carbon atom products are 1, 2, 3, 4. Yeah? And if they asked you how many total products are formed, 1, 2, 3, 4, 5, mucho, cucho, I don't even know the next spelling. So and if they asked you in one paper, they asked how many moles of HCl form? 1, 2, 3, 4. Done? Okay, moving on. This particular MCQ says that magnesium oxide is a white solid at room temperature and pressure. We already know that because it's an ionic compound, and they're usually solids at room temperature and pressure because of the strong electrostatic forces of attraction, that holds the opposite ions together in place. Boom. And so as part of the structure of solid, magnesium oxide is shown. So we usually, you know, we don't look at the structure. We just say magnesium loses 2 electrons, the oxygen gains 2 electrons to form the oxide ion, and then there's a strong electrostatic force of attraction between the oppositely charged ions. Right now, it says 3 statements are listed. Magnesium ions are smaller than oxide ions because they contain fewer electrons. No, sir. The number of electrons do not determine the size of these ions, right? It all depends on the effective nuclear charge, blah blah blah. Not in your course, but what is in your course is to calculate the electrons of magnesium and oxygen. So even if you did not know this fact, if you calculate the electrons of magnesium 2 plus and the oxide ion, you will notice is, and let me just look at the periodic table for a moment. What you will notice is that oxygen is 816 right here. Oxygen is 816 and magnesium is 1224. So if it loses 2 electrons, it's going to become 10 electrons in magnesium. And if oxygen gains 2 electrons, there'll still be 10 electrons. So they have the same number of electrons. The Reno, sir, they don't have different number of electrons. So you guys need to be smart about it. You know, there are no fewer number of electrons. They are the same number of electrons. But even if they were the same, you know, since the examiner knew that this concept wasn't in your course, so he said, hey, fewer number of electrons लिख लेता हूँ because बच्चे confuse हैं. लेकिन you would say कि hey, they both have the same number of electrons. So even if this were true, they don't have fewer electrons. So one would be wrong. Although even if the examiner had written here same, which he would never, because this is not in your course, but even he have written same, we know that it's not dependent on the number of electrons. Done. Magnesium oxide has good electrical conductivity when molten because the ions are mobile. Yes, there are free moving ions, the ions are mobile, the ions are delocalized. Done. And even in aqueous state, not just in molten. Magnesium oxide has a high melting point because of strong electrostatic force of attraction between the ions and delocalized electrons. Sir, there are no delocalized electrons. All the electrons are localized. Delocalized means that electrons are, you know, roaming about the structure, which we know is false. There's a transfer of electrons. 2 electrons go from here to here. So this magnesium ion has complete shells. The oxide ion has complete shells, you know, and the ions are free to move in molten and aqueous state, but they don't have any delocal. No ions are running, no electrons are running about. They're all in the shells, right? So 2 and 3 are correct. Therefore, C is the correct option. No, why did I say 2 and 3 are correct? 3 is wrong, my bad. 3 is wrong, yeah. I literally gave a whole fatwa about it. And I said 2 and 3 are correct. 2 is correct. D is the correct option, not 3. 3 isn't correct. 1 in the world. What am I doing? You know, I think I just got tired. Let's just finish this one worksheet. So it says, a dilute solution of sodium bromide is electrolyzed. See, it's a solution, aqueous solution, which means you're going to have the sodium ion and it says you have the bromide ion. But because it is aqueous, you would also have the hydrogen ion and the hydroxide ion, right? And because it is dilute, we know in dilute, the hydroxide ion will win the race to form oxygen at the anode, and the hydrogen will win the race, obviously, to form the hydrogen ion will win the race to form hydrogen at the cathode, because we know that the negative electrode is cathode and the positive electrode is anode, right? And from our physics we know that unlike charges attract and like charges repel. So this is a positive, it will be attracted to the negative, negative attracted to positive. And if you don't know that if anode is positive or cathode is negative, you could remember this simple acronym, which is PANIC. Positive is anode, negative is cathode. Done. So 4 hydroxide, I'll also write the equation. 4 hydroxide ion go together to give you 2H2O plus O2 plus 4 electrons. Done, sir? And if you talk about the hydrogen ion, so 2 hydrogen ions go together to give you H2 by gaining 2 electrons. Yeah. So each hydrogen ion gains an electron to give you H, and this other ion will gain an electron to give you H, and the H are going to combine together to give you H2. Yes, sir? Pretty easy. So hydrogen forms and oxygen forms. So hydrogen and oxygen. C is the correct option. Yeah, that's wrong, that's wrong, that's wrong. Because bromine doesn't form at the anode. If it was concentrated, then the bromine would form, because then the bromide ion would discharge. Which reaction of hydrochloric acid is a redox reaction? Okay. Remember, there are 3 types of reaction in the world, in your course at least. Precipitation reaction. Why have I written prep? Precipitation reaction. You have your redox reactions. And you have acid-base neutralization reaction. So it'll fall in either or either one of these categories, right? So if it's a neutralization reaction, it can't be redox or precipitation. If it's precipitation, can't be redox or neutralization. If it's redox, can't be precipitation or neutralization. Done? So this particular, you have a base here and an acid here, and acid-base neutralization reactions are not redox. And you could also check this out, right? So magnesium is +2, carbonate overall has a charge of -2, hydrogen is +1, chlorine is -1, magnesium is +2, chlorine is -1, hydrogen is +1, oxygen is -2, carbon is +4 here, oxygen is -2, and here even if you calculate this, we don't take this whole as -2, we'll take individually. Carbon, if you calculate it and waste your time, that's going to be +4 and that's -2. You could calculate it, but it'll be the same on all sides. So there'll be no change in the oxidation states. Therefore, it's not going to be redox. Again, here you have a base reacting with an acid. You guys can check it out. It's not a redox reaction, although it is a neutralization reaction. Magnesium oxide reacting with an acid, again, no, acid-based reaction. Magnesium reacting with hydrochloric acid to give you magnesium chloride and hydrogen. Yes, this is an redox reaction. Why? Because here magnesium was in its elemental state, had an oxidation state of 0, and hydrogen is +1, chlorine is -1. But here it formed a compound, and whenever it's in its compound, it'll have the same oxidation state as the charge on its ion, and magnesium makes a 2+ ion, therefore the oxidation state is +2, chlorine is -1, and that's 0. I've checked this out. Magnesium went from 0 to +2, so there is an increase in oxidation state, therefore this is oxidation. And chlorine went from -1 in hydrochloric acid. Oh no, chlorine is the same, it's -1, they're the spectator ions. Hydrogen went from +1 to 0, right? So there's a decrease in oxidation state from +1 to 0, therefore this is reduction. I'm getting tired, yeah. So D is the correct option. 20 says, which reaction mixture will produce a precipitate? Well, if you have two soluble salts and they interact with each other, they're gonna, and they can form an insoluble salt, that's gonna be a precipitation reaction. So you have sodium carbonate and copper sulfate. We literally did this, right? So if you have sodium carbonate, sodium ion, carbonate ion, they're soluble. Copper sulfate is soluble, blue solution, remember. Now if this copper ion comes into contact with this carbonates, all carbonates are insoluble except for group 1 carbonates and ammonium carbonate. But because this is copper carbonate, they're gonna be insoluble, and it's gonna give you a green PPT, right? It's green, you don't need to know if it's green. Yeah, we just checked it a while ago. So A is the correct option. That's gonna give me a precipitate. But if you add sulfuric acid to sodium hydroxide, it's gonna give you sodium sulfate plus H2O. Then that's not a precipitate. Sodium sulfate is soluble. Again, nitric acid to magnesium oxide, it's going to give you magnesium nitrate plus H2O, magnesium nitrate, all nitrates are soluble. Again, copper oxide plus sulfuric acid, copper sulfate will be formed, again, that's soluble. So D is wrong. Now, next bit says, blocks of magnesium are attached to the bottom of a steel. So magnesium is attached to steel. Remember, steel is a mixture of iron and carbon, and the only reason why you would attach it is because of this iron, to prevent this iron from getting rusty. Why? Because the magnesium is more reactive than iron, so it will have a greater tendency to lose electrons, and it will sacrifice itself, it will get oxidized itself, it will sacrifice itself to protect this iron. That says, which equation describes a change that prevents the steel from rusting? Well, this is actually, you're telling the entire world a dumb thing, that iron is losing electrons. If iron is losing electrons, then it's becoming a 3+ ion. That means that magnesium hasn't done its job. Iron will rust then. So A is wrong. Fe2O3 reacts with magnesium to give you 2 irons and magnesium oxide. Again, dude, magnesium, if you want to describe a change that prevents it, the change would be that magnesium is going to lose electrons and become ions, and it will protect this iron from getting rusty, which is only shown right here in D. Magnesium, it has a greater tendency to lose electrons because it's above iron in the reactivity series, so it's going to lose electrons, become magnesium ions, and therefore it will sacrifice itself to protect iron. So D is the correct option. Fe2O3, in Fe2O3, the examiner is already telling you that rusting has taken place. Fe2O3 is effectively rusting. It's rust, right? And if you look at C, that's also absurd. Magnesium ions are reacting with iron. You're basically telling the world that iron is more reactive than magnesium. Therefore, iron can displace the magnesium ions from its solution or from its salt, and iron ions will form in magnesium. That's just so stupid. Iron cannot displace magnesium ions, right? Because iron is less reactive than magnesium. And here again, Fe3 plus is forming. Dude, Fe3 plus forming means that rusting is taking place. What in the world? Which substances are structural isomers? So structural isomers are my neck. Yalla habibi. So structural isomers must have the same molecular formula but different. At this point, I'm so done. But different structural formula, right? And how do you know they have different structural formula? Because they have different names. If they have different names, they would have different structural formulas. Okay. So here it's saying butene and propene. Sir, it's right off the bat wrong, because but means 4 carbons and prop means 3 carbons, so they can never have the same molecular formula. You can check it out. Ethyl ethanoate and butanoic acid. We'll come to this in a while, but I'll first of all eliminate D out, because it's saying propan 1-ol and butan 1-ol. Again, prop means 3 carbons and but means 4 carbons, so they can never be isomers. Now the option is between B and C, right? Right off the bat, I could safely say that B is the correct option, but let's prove it out, right? So ethyl ethanoate, that's an ester and that's an acid. So they can be isomers, because this type of isomerism is known as functional group isomers. So structural isomers further has 3 categories. Chain isomers, chain isomerism, in which we branch the length of carbon chain, vary the length of carbon chain. Then you have position isomers, where we shift the position of the functional group. And then you have the functional group isomers, where the entire functional group is different. So in this case, you are having an ester and an acid. But if you make ethyl ethanoate will look something like this, right? So this came from ethanoic acid, and that's why ethanoate, and this came from ethanol, that's why ethyl. And if you count out the number of carbons and hydrogens and oxygens, they'll be the exact same as of butanoic acid. So that's butanoic acid. And if you count out the number of carbons, you have 4 carbons in butanoic acid. And you could also do it like this. If you have 3 carbons, C3 H7COOH. You could use the general formula, right? CnH2n plus 1. So if 3 carbons, hydrogen will be twice the number of that, plus 1, COOH. So if 4 carbons, 8 hydrogens and 2 oxygens. If you count this out, you'll have 4 carbons, 8 hydrogens and 2 oxygens. But in this case, you won't have the same number of carbons and hydrogens. You could check it out, right? Maybe the carbons are same, but not oxygens. You could check this out, right? So methyl methanoate, without even drawing it, because it is an ester, it has 2 O's, one here and one here. But ethanol only has 1 O, which is of the OH, right? So they don't have the same molecular formula. B is wrong. Why did I cancel out C? My God. Why did I cancel out C? Wait. What's wrong with me? So at this point, my brain is just going nuts cuckoo. I'm just putting crosses everywhere. Why, Suleiman? Why? So C is the correct. B is the correct option. What am I doing, man? To be honest, I think that's the cue telling me to stop. But okay. Yeah, so B should be the correct option. And that's pretty much that. We'll continue the MCQs in the next bit. Yeah, these are more questions. So I've combined them in a single worksheet. That's why I've put my logo on it. Otherwise, I have not made this, right? But students sent this to me. And I was like, sure, man, why not? We'll record it for you. So I'll do the next in a few days. Not in a few days, maybe tomorrow I'll do it. Okay, bye-bye, ciao, see you, bye, Allah Hafiz.